Guys, and welcome back. This is the video that'll go with our day 12 notes, solving systems using elimination, day 1. And so we're going to use math operations and solve systems of equations by elimination. And to do that, we're going to need to multiply one equation to create an opposite pair in order to solve. So like I said, we want to create an opposite pair. The word elimination means to get rid of something. We're eliminating it, we're removing it from our equation. And so to do that, we need opposite pairs. So we want the coefficients of one of our variables to have opposite pairs. And that is our goal. So the steps that we're going to use is that we're going to make sure we've lined up our equations so that all of the x's are together, all the y's, all the constants. Then we're going to multiply one or both of our equations to create coefficients that are opposite pairs. We'll add the equations to eliminate the variable from step 2, then solve for the remaining variable. The last thing we'll do is substitute our answer into the original equation and solve for the other variable. Remember, we're still finding an ordered pair because we're still talking about two lines that are intersecting. So we'll still write our answer as an XY ordered pair. We do have a little cheat here for you for the special cases. If you end up with 0 equals 0, then your answer is infinite solutions. If you end up with 0 equals some number, then your answer will be no solutions. So let's work a few examples. So let's start here down here at number 4. The first thing we want to do is make sure our x's are lined up, our y's are lined up, and our constants. So we see that we have x's stacked, y's stacked, and constants stacked. Since they're all stacked, I don't need to change that. And I just want to look at my coefficients. So I see that here I have a -1 and a +1, which is an opposite pair. Since that's an opposite pair, I don't need to do anything else. And it doesn't matter what the other ones are. When you have an opposite pair, you can go straight to adding your two equations. So we're going to combine them. And we can do this because you can do anything to a set of equations, provided you do it to everything. So -x plus x will cancel because that's 0x. 2y plus 3y gives me 5y, and -14 plus 9 is -5. Since the 0x went away, we're just left with 5y equals -5. Then we're going to divide both sides by 5 to leave us with y is equal to -1. Once you've solved for one, you can solve for the other. So we're just going to take our y equals -1 and substitute it back in for y in either one of our equations. It doesn't matter which. So I have -x plus 2 times -1 equals -14. Then I just solve like normal. Multiply the 2 and -1 to get -2. Add 2 to both sides. And then finally divide by -1. So then we get that x is equal to 12. We're still talking about systems of equations and lines intersecting. So I know that my answer is now going to be 12, -1, because x comes first. And this is just a consistent system that intersects at one point. Let's do another. Let's take a look at number 5. I can see right off the hand that the x's are stacked, the y's are stacked, and the numbers are stacked. So I don't need to move anything around. And then I notice that my -2x and my 2x are my opposite pair. So I can go straight into adding my two equations together. When I add, I get 0x minus 13y equals to -13. Because at 0x, my 0 just goes away because 0 times anything is 0. Dividing my -13 gives me that y is equal to 1. Then I'm just going to take my 1 and plug it in for y in either one of my equations. It doesn't matter which. So I'm at 2x minus 7 times 1 is equal to -1. Solving that out, I do -7 times 1, which is -7. Add 7 to both sides. So 2x is equal to 6. Dividing by 2 gives me that x is equal to 3. That means that my answer is 3, 1. means my two lines intersect at the point 3, 1. Moving on to number 6, I see that my x's and y's and numbers are all lined up in the right spot, but that I don't have an opposite pair. My y's are both positive, which means that they have the same coefficient, but they're not opposite. So in order to make an opposite pair, I'm going to multiply one of my equations by -1. Remember, you can do anything you want to an equation as long as you do it to the entire equation. So when I do that, I get positive 3x minus y equals positive 5. This creates my opposite pair, so I can add my two equations together and get that 0y that I want. I can now jump down and say that 11x is equal to -11. My last step is to divide by 11, which gives me that x is equal to -1. It's important that I always remember which variable I solved for, because that's the variable I'm going to substitute back in for. So since I have x, I'm going to plug -1 in for x. I'm going to go into the top one this time. So I'm at 8 times -1 plus y equals -16. 8 times -1 is -8. Adding 8 to both sides gives me that y is equal to -8. So my final answer is the point -1, -8. Again, I have two lines intersecting at one point, and that point is -1, -8. Let's do one last problem, and that be number 7. When I look at number 7, once again, I see that my variables are lined up appropriately. But I don't have an opposite pair. I see that I have two -6's, but when I add those together, they would not give me a 0. They'd give me -12. So I need to multiply one of my equations by -1. So when I multiply by -1, I get positive 6x minus 6y equals to -6. And then I'm just going to carry down my second equation as is. I can then add my two equations together to see that my 6x plus -6x gives me that 0x, -6y plus 3y is -3y, and -6 plus -12 is -18. Again, that 0x can go away, leaving me with -3y equals to -18. Dividing by -3 to both sides, I get that y is equal to 6. I can then just take my 6 and plug it in for y in either equation. So -6x plus 3 times 6 equals -12. Multiplying the 3 and the 6, I get -6x plus 18 equals to -12. I can then subtract 18 from both sides, giving me -6x is equal to -30. Dividing by -6 gives me that x is equal to 5. So I know that my final answer is the point 5, 6. Again, an intersecting system that is consistent. If you have any other questions, please be sure to ask me, and I hope that this helped you understand some more of the problems. See you later.